Hello student, welcome to Mathologic, and today we will discuss about NCERT solution integrals for your board exam, class 12 board exam. We already made part 1 video. I just sent the link in description box, and that is part 2 video for integral suggestion. This question comes from exercise 7.5, question number 1. It is given that we have to integrate x dx divided by x plus 1 x plus 2. So we write it as 2 into x plus 1 minus x plus 2, that is equals to 2x plus 2 minus x minus 2, that is equals to x. So in the place of x we put this. So we get 2 into x plus 1 minus x plus 2 divided by x plus 1 x plus 2 dx. So we get 2, x plus 1 cancel out. We get dx by x plus 2 minus integral dx by x plus 1. That means 2 log x plus 2 minus log x plus 1 plus c. That is the correct answer for this question. Now we discuss about second important question. From exercise 7.2, question number 16, it is given that integral dx by x into x to the power n plus 1. So we write it as, if we multiplied x to the power n minus 1 in numerator and denominator both, then we get x to the power n minus 1 dx divided by x to the power n into x to the power n plus 1. Now we take x to the power n as t. If we derivative x to the power n, we get n into x to the power n minus 1 dx is equals to dt. So we get x to the power n minus 1 dx equals to 1 by n dt. So we get 1 by n integral dt by t into t plus 1. So we write it as 1 by n integral t plus 1 minus t divide by t into t plus 1 dt. That means 1 by n integral t plus 1 cancel out. So we get dt by t minus integral dt by t plus 1. That means 1 by n log t, that is log of x to the power n minus log of x to the power n plus 1 plus c. And that is the correct answer for this question. Third important question from exercise 7.5, question number 19, given that integral 2x dx divided by x square plus 1 multiplied x square plus 3. So first we take x square is equals to t. If we derivative x square, we get 2x dx is equals to dt. So we write it as dt by t plus 1 t plus 3. We get t plus 3 minus t plus 1 divided by t plus 1 into t plus 3 dt. T and t cancel out. 3 minus 1 equals to 2. So we have to put half outside the integral. 2 and half cancel out, right? Now if we divide into two parts, then we get half of integral t plus 3 cancel out. So dt by t plus 1 minus integral dt by t plus 3. So we get half log of t plus 1 minus log of t plus 3 plus c. That means half log of, in the place of t we put x square. So x square plus 1 divide by x square plus 3 plus c. We know log a minus log b equals to log a by b. That means this one is the correct answer. I hope you enjoy the video. If you have any doubt in integral, then comment below, subscribe the channel and share with your friend. Fourth important question comes from exercise 7.6, question number 6, integral x log x dx. This question comes from integral by parts, x log x dx. So we use the integration by parts rule for that question. So we take log x then integral x dx minus ddx of log x. So we write ddx of log x multiplied integral x dx dx. So what we get? Integral of x dx, that is x square by 2 log x minus ddx of log x, that is 1 by x multiplied by x square by 2 dx. So these x and x cancel out. We get x square by 2 log x minus half of integral of x dx, that is half of x square plus c. That means x square by 2 log x minus 1/4 x squared plus c. And that is the correct answer for this question. Another important question from exercise 7.6, question number 19, integral e to the power x multiplied 1 by x minus 1 by x squared dx. This question comes from integral by parts. We write it as integral e to the power x 1 by x dx minus integral e to the power x 1 by x squared dx. So we write it as 1 by x integral e to the power x dx minus ddx of 1 by x integral e to the power x dx minus e to the power x into 1 by x squared dx. So we get e to the power x by x minus of ddx of 1 by x, that is minus 1 by x square. So minus of minus, that is plus integral 1 by x square e to the power x dx minus 1 by x square e to the power x dx. This one cancel out. So we get e to the power x by x plus c. That is the correct answer for this question. I hope you enjoy the video. Part 3 integral solution coming soon. Subscribe the channel for more videos. Thank you.